Hey Chem Kids, Mr. C here, and today we're going to be performing the Density of Germanium lab. What you're going to need for this lab is actually located right below this video in our Density of Germanium module, and it's going to be the lab guide. So go ahead and open up that lab guide in Google Docs, because you're going to want to record the data in the data table as we complete the lab. So you're probably going to want to have your browser split screen. So on one screen you have the video up, and on the other screen you have the lab guide up. Welcome back. Now that you have your lab guide up, our first thing that we're going to do is we're going to figure out what the density of tin is. So, we know that density is going to be mass divided by volume. So the first thing we have to do is we have to figure out what the mass of our sample of tin is. In order to do this, all we have to do is place our sample, which in this case is a little cylinder, on our scale. And we're going to record the mass of that cylinder in grams, which is what is displayed on the screen, in our data table under the mass of the metal, under the tin column. So go ahead and do that now. Record that number. The next thing we have to do is we have to figure out what the volume of our tin sample is, or sample of metal. And there's a couple ways we're going to do this, or there are a couple ways you could do this. But in this lab, we're actually going to use the water displacement method. And all that is we have our graduated cylinder full of water, and we're going to measure the initial volume of water in that graduated cylinder. Then we're going to place our sample inside the cylinder. It's going to raise up, and we're going to have that final volume of water in our cylinder. The difference between those two values will be the volume of our metal. So go ahead and make your best measurement here of what the initial volume of water is, and it looks like it's right between that sort of 78 and 79 mark, and we're going to measure it out to the nearest 0.1 millimeter. Feel free to pause the video if you want to take a closer look at the reading. The next thing we do is we carefully place our sample into our graduated cylinder. We don't want to dump it in there because we don't want to break it. And now we're going to measure the final volume of water in our cylinder, which is, as you can see, is higher than the initial volume. So we're going to look very closely, and just in case you can't get a good look, it looks like it's right between that 86 and 88 millimeter mark. So once again, we're going to measure it out to the nearest 0.1 millimeter. Once again, feel free to pause this video if you want to get a better look and make a very good, clean measurement. After you make your measurement, we're going to find out what the volume of our metal is. And in order to do that, we're actually just going to take the final volume of water in our cylinder minus the initial volume of water in our cylinder. And that's going to be what the volume of our metal was. Pretty cool, right? That's the water displacement method. So you're going to go ahead and record that number in the volume of the metal spot in the data table. The next thing you have to do is you have to look up what the atomic number of tin is. And you're going to have to do that on. You can go ahead and look at your periodic table to do that. Okay, so the next thing we're going to do is we're going to find out what the density of lead is. And in order to do this, we need to first take what the mass, or find out what the mass of our sample of lead is. So we're going to go ahead and place that sample on the scale, and we're going to record that value there, which is in grams, in our data table under the mass of metal for lead section. So go ahead and record that number. The next thing we need to do is record whatever the initial volume of water in our cylinder is. So if you can look very closely, it looks like it's right around that 76 milliliter mark. Remember, we're recording this number to the nearest 0.1 milliliters. So feel free to pause this video if you want to make a better measurement and get in nice and close and see what that value is. And record that in the initial volume of the cylinder spot on the data table. Our next step is we're going to carefully place our sample of lead into our graduated cylinder. And careful is the key word here, because we really don't want to break that graduated cylinder, because that would make a whole lot of people unhappy, and I don't really want to clean up glass on any day, really. Now we're going to look closely, and we're going to once again measure what the final volume of water is, and it looks like it's right around that 78 milliliter mark. So go ahead and record that in your data table to the nearest 0.1 milliliters. Once again, feel free to pause the video. Now you have to calculate what the volume of the metal was, and we're going to do that in the exact same way that we did for tin. We're going to just take our final volume of water minus our initial volume of water, and that difference in volume is actually the volume of our sample. Now all you have to do is look up what the atomic number for lead is. Now we're going to do our final experiment. We're actually going to figure out what the density of silicon is. But we have to do this a little differently because we don't have as nice of a sample of silicon. So the first thing we're going to do is we're actually going to pour some silicon pellets into a beaker, and we're going to measure what the total mass of that beaker is. We're going to record that in the section that says the initial mass of the beaker under the lead portion. It's going to be at the very top of your data table. So go ahead and record that mass in there. And once again, it is in grams. The next thing we're going to do is we're going to record what the initial volume of water is in our graduated cylinder. And if we look closely there, it's right around that sort of 55 milliliter mark. Go ahead and measure that out to the nearest 0.1 milliliters so that we can have a nice measurement there to work with. The next thing we're going to do is we're actually going to take some of our silicon sample and we're going to carefully put it into our graduated cylinder. This is, once again, the water displacement method, and it's how we're going to figure out the volume of our sample of metal is. But it's also going to tell us what the mass of the metal is, and we're going to go over that in 1 second. So we're actually going to reweigh our beaker now, and we're going to record that number in the final mass of the beaker section of our data table under silicon. And the difference between our initial mass and our final mass of the beaker is actually going to be our mass of the metal. So go ahead and do that initial mass minus the final mass of the beaker, and that number there is the mass of the metal. And you can record that number in your data table as well under the mass of the metal for silicon. Pretty cool, right? Our next step is we have to once again measure the final volume of water in our cylinder. Pretty cool. I'm going to give you a few angles on this because it can be kind of hard to see, but we're going to look very closely and we're going to try and get a nice measurement of what the final volume of water is in our cylinder. And if we look closely, it looks like it's kind of hovering right there around that sort of 57 milliliter mark. So go ahead and record the final volume of our water in our cylinder to the nearest 0.1 milliliters. Your next step after you make that measurement is you're going to want to take the final volume of our sample of water minus that initial volume, and that is going to give us what our volume of metal is. Pretty cool. And you're going to record that in your data table, as long as look up what the atomic number for silicon is and record that in the data table as well. Next, you're going to answer the rest of those questions on your lab sheet. If you have any problems with the graphing, I'm going to make a short video on how to sort of graph with that Google Doc and the graph that's embedded within the Google Doc. There are directions in the Google Doc, but if you can't follow them or you would prefer to watch a video kind of me showing you how to edit that graph, feel free to. The video will be right below the graphing assignment. You do not have to watch that video if you want to. If you have any questions, just ask your teacher. They will be more than happy to help you out.